Assalamualaikum and good morning to our lecturer Dr. Arifah binti Che Alhadi. We are group 4 for subject CSF 3243 Computer Organisation and Architecture. Today we are going to present our group assignment, which is project 5, influence of the mapping for different cache size. Our presenter is Nur Atila Syafiqah binti Muhammad Nazi as 62575, Nurhani Shakila binti Muhammad Zailan as 62611, Muhammad Ashraf bin Muhammad Murizan as 62368 and Muhammad Rafi Ilman bin Rusli as 63702. For introduction, a CPU cache is a hardware cache that lets us access time to information in memory. The simulation is predicated on a model built around the underlying architectural principles of those systems. The performance of computer system depends on the performance of all individual units, such as execution unit like integer, floating point, I/O unit, bus, cache, memory system. The basic segment in most high-performance PCs is the cache. Cache performance relies upon cache hits and cache miss, which are the elements that make requirement to system performance. A cache hit is a state in which data requested for processing by a component or application is found in the cache memory. A cache miss is an event in which a system or application makes a request to retrieve data from a cache, but that specific data is not currently in cache memory. The hit rate is the fraction of memory access they are found in the cache, and the miss rate is 1 minus h. Miss rate can be decreased by involving cache size, block size, and associativity. The initial step to diminishing the miss rate is to comprehend the reasons for the miss. The miss can be neglected compulsory, capacity, and conflict. Compulsory miss is also known as quick start miss or first reference miss. This miss occurs when the first access to a block happens. Block must be brought into the cache. Next, capacity miss. This miss will occur when the program working set is much larger than the cache capacity. Since cache cannot contain all blocks needed for program execution, so cache discard this block. For complete miss, it is also known as collision miss or interference miss. This miss occurs when several blocks are mapped to the same set of block frame. This miss occur in the set associative or different net block replacement strategies. So the purpose of the project is to show the influence of the mapping on the miss rate for several cache size. For hypothesis is if cache size increasing, then miss rate decreasing. Then there are some variables that have been identified in this project. First, for manipulate variable is cache size. Second, for responding variable is miss rate, and last constant variable is block in main memory. So I will pass to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So I will make a video about to run the demo for the project 5 SMP cache. The topic is influence of the mapping for different cache size. First of all, you have to open the SMP cache as shown as my video. So before we start to set up all the development, we should click on the multiprocessor, memory, and cache. All the development or maybe all the configure we should set up on based on the project we have. So my project 5. At first we can set up on the multiprocessor first. So we should have processor in SMP equal to 1. So means that memory relation in SMP and number of processor we should have 1. So next, cache coherent protocol. Cache coherent protocol same as Snoopy protocol, so we should change to an ESI. And bus activation, as in the project we should have skin bus activation, so we should choose the random. If you have done for the configure multiprocessor, you can click the OK that you can save your setup based on your development. Next, for the configure memory, for our project is worldwide, so worldwide should have 32, so I have to decrease this number. Word by block which is 64, so also I have to decrease this number. And when you change the words by block, you should automatically get the block size. If I change to the lower 64 to 2, we have 1 to 8 bytes. So my project we have should 64 words by block, so we can get 256 bytes. And for the last, for the configure memory is word by block. So For the last is words in memory, block in memory, we should have 4096. So we should increase this number, and automatically we have 1 megabyte. But surprising, we should have 1024 kilobyte. But when we change the block in memory, we have 2 megabyte, 1 megabyte. So as the conversion, we should have 1 megabyte equal to 1024 kilobyte. So it doesn't matter. So we have that the configure memory as development. We should have this kind of project. So we click on the OK. And for the last configure cache, for the cache level, we should have 1, so level 1. So block in cache size, we according to the test 1, because of my project, we have no development for the cache according to test 1. So we have 5 mapping that we should run all the SMP cache, which are direct, 2 ways, 4 ways, 8 way, and fully self-sweating. So block, we should have 4 KB or 16 block in size, block in caches. So we have to decrease this block in cache until 16 as 4 kilobyte. So if you want 4 kilobyte, we have block 60. If you want 32 kilobyte, you should increase this block in cache until you have 32 kilobyte. So 32, we should have 128 block in cache. So as I have to 16 only for the kilobyte, and mapping, I will go first to direct. So no replacement policy. Either you use the set or fully, we should have replacement policy. As my project, we should need the LIU. So we choose the LIU based on your project. So I will go for the mapping, direct mapping. So I have done the configure cache. So okay. And open the replace. Open the traces folder and the RG folder. As our project, we should have year tracer. So click on that, so we can get trace file year.prg. So okay. And when you want to see the result, either text or graphic, we should view on innovation. So we click on cache, text or graphic according to the group. So I choose the text because of my group use the text and graphic also. So okay. And before you execute, you should change it to complete and execute. So as the test, we want to study about the message, so we tap the hit list. So we wait a little bit for the complete one. We have done the first direct mapping, which is 4 kilobyte. Oh yeah, before I forget. So if you want to check of your development, you can check for this information type. We have memory relation, SMP, number of missing one, swapping protocol is MESI, bus attribution is random, direct protocol is no because we have no development for direct protocol. And word 32. Why our group is directory protocol? Because of we are using the direct mapping. So block size 256 byte and memory size 1 megabyte, cache size 1 kilobyte. So if you want to recheck, you can check the information in the information tab. So you can exit and cache as a graphic. You also do something. Click on graphic, okay. Before execute, please choose the complete and execute. So we have to wait a minute, and so this is the graphic for the direct mapping 4 kilobyte. And also I will run for the next cache size, which is 8 kilobyte. So when we want to change the cache size, we should open the configure of cache only because of multiprocessor and memory. We have then save it. So okay. We have changed this. So we want to 8 kilobyte. So we have to decrease block in cache 32. Okay. And we do something, open the replace, click. Ensure the tick equal to trace file you want. So okay. And build version is cache and text. Okay. The same. Complete and execute. Also we want to limit it. So we click on the hit list. So before that, we should have this information also when we run the hit list or we run the configuration. So number of load 32, mapping direct, replacement required, no, because of we are using direct mapping. So this is the final result of direct mapping 8 kilobyte. So easy. So for the next cache size also we use the same things. We should click on configure cache and we have to decrease the port size. So 64, 16 kilobyte. Okay. Build version cache. That's okay. So execute, complete, execute, and click on hit me so that we can get the message. This is the final result for direct mapping, 16 kilobyte. So as the next configuration, so we have to exit. So for the next cache size, we open the configure cache and increase the snap block in cache because of we want to 32 kilobyte as the test one. So 128 block in cache. So okay. Visualization cache text graphic, I will choose that because my group prefer text. Okay. Step by step we change to complete and execute, and don't forget to tap on hit list. So final result for the direct mapping 32 kilobyte. So this is the final result. Okay, so exit. Next, I have done for cache in size difference. So I will go next for the next, which is 2 sets associative. We have done set of the configuration multiplexer and configure memory. We have done the same development, and we should click on the OK. We just change at the configure cache because of we want to set 2-way sets associative. So we choose mapping set associative, cache size 4 kilobyte and 16 byte cache. So how to get the 2-way set associative is like log in cache divided by cache set equal to 2. So we have 16 divided by watts to get 2. So 16 divided by 8 equal to 2. So we have 2 set associative. So the first basic is LIU based on the so okay. Parameters and show this tip. So we forget the G here and click this. So okay. View operation, click on cache, text or graphic based on your group. So I will go to graphic. Okay. And before we execute, change step by step to complete and execute it. So this is the final result for 2-way sets associative on 4 kilobyte cache size. So exit. So next for the 4 kilobyte, and the next is 8 kilobyte. So 32 per in cache. So we can get 8 kilobyte. So cache set we should increase 1. So 32 divided by 16 equal to 2. So 2-way set. So okay. View operation cache format text. Okay. And before execute, change this to complete and execute. And don't forget to click on tap it because of we want to receive only. Final result for 8 kilobyte cache size for 2-way sets mapping. So exit and then you can save it. So the next cache size, I will change the configure cache into 16 kilobyte. We want to 16 kilobyte. And block cache is equal to 64 as we want to set the 2-way set associative. We should increase this, so 64 divided by 32 equal to 2. So we can get the 2-way set associative. So okay, and the operation cache. That's a graphic depends on the group, so that's okay. And change this to complete and execute. Also click on hit list. Then execute for the 16 kilobyte of 2-way set associative. So exit, go to the next cache size, which is 32 kilobyte. So I have to decrease block in cache, and you can get 32 kilobyte. So cache set we increase to 1 because we want the only 2-way sets associative, which for the formula 1 to 8 divided by 64 equal to 2. So we can get 2 sets associative. So okay, if you're using cache, I will go to the text again and okay. Step by step, change to complete and execute hit results. This is the final result for the 2 kilobyte of 2-way sets associative. So exit here for the next mapping, which is 4-way set associative. So as usual, configure multiprocessor and configure memory are saved according to the environment that we have set up. In the first, you open the SMP cache, so okay and okay here. So we just change a configure cache. So we want the 4 kilobytes, so we should decrease this block in cache. So until 4 kilobyte and 16 block in cache. as a set associative that we want 4-way set associative. So that means 16 divided by y equal to 4. So 16 divided by 4. 16 divided by 4 equal to 4. So is it 16 divided by 4 equal to 4, so we can get 4-way set associative. So okay, open meters and show this step are 8. Okay, and build relation, catch text on graphic according to new group. So I'll go with the text. Okay, step by step, simply complete, execute, and show this step. This is the final result for 4-way set associative of 4 kilobyte of cache size. So exit and don't forget to save your configuration. So after that, we have to change the block in cache to get 8 kilobytes. So we have to decrease this. And we want 4-way set associative, so that means 32 divided by cache set equal to 4. So 32 divided by 8 equal to 4. So we can get 4-way set associative. So okay, build relation is cache. As a text and okay, step by step of check to complete and execute. So hit resist. And this is the final result for the X kilobyte of 4-way set associative. So this is 8 kilobytes of cache size. So exit and don't forget to save. Next for the cache size 16 kilobytes, so we have to decrease this block in cache until we get the 16 kilobytes. So for 16 kilobyte, we should have 4-way set associative. That means 64 divided by cache size equal to 4. So 64 divided by 16 equal to 4. So okay, view operation, set on cache. So text of graphic according to the group. So I will go to text, okay, and hit insert. Before execute, please change to the complete and execute. This is the final result for the 16 kilobyte of 4-way sets associative. Don't forget to exit and save the configuration. So for the last cache size, it is 32 kilobytes, so we have to increase this block in cache, so until 128 divided by 32 can get equal to 4. So we can get 4-way set associative. So okay, and view operation of cache, text, okay, hit insert, change this to the complete and execute. The final result for 32 kilobyte of 4-way set associative. So you can exit and don't forget to save your configuration. Okay, for the next mapping, we should run on the 8-way sets of associative. So configure multiplexer and configure memory, we should make by setting up a meeting. So just click on the OK and the configure cache. So we should have 4 kilobyte cache size. So we have to decrease this block in cache until we can get 4 kilobyte. So 4 kilobyte, we get 16 block in cache, and we want to 8-way set associative. So that means 16 divided by 2 equal to 8. So that we can get 8-way set associative. So okay, and open memory trace, ensure this table are clicked, and view operation, cache, text or graphic, I will go to graphic, okay, step by step, to complete, and click and execute. This is the final result for the 4 kilobyte of 8-way set associative. Okay, next we go to the 16, we go to the 8 kilobyte, which is 32 block in cache. So 32 divided by 4. 32 divided by 4. 32 divided by 4, or 4 times 8 equal to 32. So okay. Listen, cache, graphic, okay. Change step by step to complete and execute. This is the final result for the 8 kilobyte of 8-way sets associative. So exit and don't forget to save your configuration. So to the 16 cache size, we have to decrease this block in cache. So cache set 84 divided by 8 equal to 8. 8 times 8, 64. So okay, and vibration cache, graphic, okay, step by step to complete and execute. This is the final result for the 16 kilobyte of 8-way sets associative, so exit, and don't forget to save your configuration. For the next sketch size, we have 32 kilobyte, which is 1 to 8 block linkage, and 1 to 8 times 16. 16 times 8 equal to 1 to 8, so we can get 8 ways associative, so okay. And build version package, graphic, okay. Don't forget to change this to complete and execute. This is the final result for the 32 kilobyte of 8-way associative exits, and don't forget to save your configuration. Okay, for the next mapping, which is fully associative, so as usual, multiprocessor and memory, we can change anything, so just click on the OK. So for the fully associative, we can choose the fully set associative mapping, that which is the lowest cache size for 4 kilobyte, so we change the package until 16 and we can get 4 kilobyte. So preset is can replacement of the chooses because of the fully associative. So value 50. Upon meters according to this project. So okay, and view relation page. Text on graphic, I will go to text. I will go to graphic. Okay. And change to the complete execute. The final result for the 4 kilobyte of fully set associative. We can exit and save configuration. Either you can choose view cache information by format text. So okay. Don't forget to change the form to complete. Hit missing step and execute. The result for the 4 kilobytes of fully associative as the text format. So it's the final result. So you can exit and you save configuration. So for the next cache size, I will change to the block cache until the 8 kilobyte. So 32 block and fully associative, and also align reinforcement policy. So okay. And view cache evaluation, graphics, okay. Before execute, please change this into the complete and execute. Final result of 8 kilobyte for fully set associative, and you can exit and also you can save your configuration. And after that, you have the cache size, which is 16 kilobyte, so you have to increase the block in cache 64, and we have 16 kilobytes. So okay, view cache evaluation and graphic, okay. Before start, change to complete and click on execute. The final result of 16 kilobyte based on graphic format for fully associative. So you can exit and also you can save configuration. And the last one is the 32 kilobyte of cache size. So we have to increase the block in cache until 1 to 8 so that we can get 32 kilobyte. So okay, and view and use cache into text or graphic, we will go to text for the last one. Okay, change step by step to the complete and execute. Don't forget to click on hit me step. This is the final result for the 32 kilobyte of fully associative by using text format. So exit, or maybe you can see the view version of graphics. So okay, change to the complete and execute. For result about 32 kilobyte of fully associative in format graphic. So we can go more understanding when we use the text format. So you exit and save your configuration. I think that's all the run demo for our project, which is project 5. So that's all from me, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. So before I present about my part, so I would like to introduce my name first. My name is Nurhan Shakila binti Muhammad Zalan, and you can call me Anis. So for the task 2, the question is, does the miss rate will increase or decrease as the SIT grades increases? Why? What does will it happen with the conflict misses when you enlarging the SIT grade? So for the answer is yes, the miss rate will decrease when the SIT increases. It is because on the grounds that SIT will permit square to travel some age in reserve, and most square sets are averse to overrides. So when enlarging the SIT grade, the conflict misses will decrease significantly. This happens in light of the very fact that SIT will just influence target misses. So I can conclude that the miss rate will decrease when the SIT increases. Also maybe can the miss rate will increases as the SIT decreases. So the impact of the increases and decreases the miss rate is because of the permit square that travel along the reserve and and square per sets are more averse to overlap. So is the answer for the task 2. Next, for the task 3, I read about the question, does the influence of the anxiety grade increase or decrease as the cage size increases? Why? So before I will explain about the answer, I will explain a little bit about the mapping. So we have 5 mapping which are direct mapping, 2-way set associative, 4-way, 8-way and fully set associative. For the first mapping, direct mapping, we can see that the miss rate will increases or miss rate will decreases when the cage size are increases. So when the direct mapping, we can see that when we have 4 kilobyte of cage size, we have the highest miss rate, and when we have 32 kilobyte of cage size, we have the lowest miss rate for the direct mapping. Also next, we go to the 2-way associative mapping, and again we can conclude that miss rate will decrease when the cage size are increases. So for 4-way associative and 8-way also fully associative, we also can conclude that the miss rate decrease as the cage size decreases. So for the explanation of answer for task 3, I say the associative decreases as cage size increases because of the advantage each time shorter. That means that when we have the highest cage size, we can save some time to get the program run at the shorter time. So this coincident with the idea that complete miss are reduced by increasing the associative. However, because the cage size increases, the kinds of misses are less affected. It can be shown in figure 1 or the graph that I have explained just now. When the rise in the associative is incredibly similar between the 8-way associative and also the fully associative set. So when you can refresh back, we have almost same between 8-way set associative and fully set associative. So and the last task for the project 5 is task 4, which the question is, does the increase of associative improve the system performance? If the answer is yes, which is the step with more benefit, from direct to 2-way, or maybe from 2-way to 4-way, or from 4-way to 8-way, or so can be from 8-way to fully set associative. Generally, we can say the answer is yes, because of an increase in society will improve the system performance. From direct to 2-way set associative is the most beneficial step. Also can say from direct to 2-ways are the most benefit we can get. So it's because the miss rate will decrease in maximum. The system will improve the performance at this step. So that miss rate decrease, so the cage size also increase, and the system bring the best performance at all. So I think that's all from me to present about my parts, which is task 2, task 3 and 4. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Ashraf. Based on the task given, this is the result that we obtained for different mapping. The first cage size we use is 4 kilobyte with direct mapping, and the hit rate is 87.66%. The miss rate is 12.34%. After that is 2-way set associative with the hit rate 91.69%, the miss rate 8.30%. Next, with the 4-way set associative, the hit rate is 93.36% and the miss rate is 6.63%. After that, we use 8-way set associative. The hit rate is 93.4%, with the miss rate is 6.59%. And the last but not least is the fully associative. The hit rate is 93.46% and the miss rate is 6.53%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rafi'il Berusli. Will present to you about the observation of our project. So the observation of our project is about the miss rate and the hit rate of for the different mapping for the different cache size. So from the table 1, we can see this is the table for the hit rate and the miss rate value using different mapping for the cache size for kilobyte or for KB. We can see from the table there is a five different mapping, which is direct, two-way associative, four-way set associative, eight-way set associative, and fully associative. So we go to the first one. The first one of mapping, the result, hit rate and the miss rate. The direct mapping, the hit rate is 87.660%, while the miss rate is 12.340%. For the two-way set associative, 91.692%, and miss rate is 8.308%. For the four-way set associative, the hit rate is 93.369%, while the miss rate is 6.631%. For the eight-way set associative, 93.406%, and miss rate is 6.594%. And the last one is the fully associative, the hit rate is 93.463%, and the miss rate is 6.537%. So what we can learn from this table, the hit rate is from the direct mapping to the fully associative, the value of the hit rate is increasing, but the value of the miss rate is decreasing. For the table 2, is same result, hit rate and miss rate, but the different cache size, which is 8 kilobyte or 8 KB. So what we can learn, the pattern of the result is the same, which is hit rate is increasing, while the miss rate is decreasing. For the table 3, the cache size is 60 KB. So the pattern of this result is also the same, which is hit rate is increasing, the miss rate is decreasing. And the last one for the cache size of 32 KB is also the same, which is hit rate is increasing, miss rate is decreasing. So what we can learn from this table, I will tell you about the lowest value of hit rate, the highest value of hit rate, and the lowest value of miss rate, and the highest value of miss rate. For the lowest value of hit rate goes to the direct mapping at cache size per kilobyte, which is its value is 87.660%, while the highest value of hit rate goes to the cache size of 32 KB at fully associative, which is 97.664%. And for the miss rate, the lowest value of miss rate goes to the cache size 32 KB at fully associative, which is 2.336%. And the highest value of miss rate is at cache size per kilobyte or per KB at the direct mapping, which is 12.340%. So what I can conclude from our observation, the value of hit rate and is increasing while the miss rate is decreasing when the cache size is increasing. So I think that's all from me. Thank you.
So, in conclusion, cache memory is used to minimize the average time it takes for the main memory to access data. The cache is smaller than quicker memory that holds copy of the data from the main memory locations that are often used. In a CPU, there's many different independent cache with whole instruction and information. The goal of this research is to influence the mapping of different cache size. So, the increase of associative improves the system performance. The system efficiency does improve the increase the associative ways, but the maximum efficiency improvements is from direct to two-way set associative mapping. Thank you.